Hey,
Uh, our guest speaker, KJ6ER, Greg hails from Northern California. And Greg's a big POTA guy. And I know he's made contacts with a number of people here in the room. And I believe, Ryan, you've spoken with Greg on the air as well. So I'm going to turn everything right over to Greg. And KJ6ER, thank you, Greg. The floor is yours.
oh, thanks so much. And everyone always likes me to say, make sure you're all muted so we don't get those HT squawkings going on in the background. That's it, Ralph, even you. All right, folks, I'm going to apologize in advance because normally this goes for an hour and a half, sometimes 2 hours, depending on Q&A. I'm going to do this in an hour. So I'm going to go a little bit faster than normal, but I will pause once in a while for questions because I love interaction. But unfortunately, I have about an hour, maybe an hour, 2 minutes at most. So there we go. So let me hit the share button. And I think I can do this. If I hit that and I hit share, I will ask the question that people love to. Can you see my slide? Give me a thumbs up. Or
Yes.
yes. Okay. So I can go forward. All right. Let me go to the first slide and I'll keep moving. Yeah, thanks for the introduction. My name is Greg Mihran, Kilo Juliet 6, Echo Romeo, based here in Silicon Valley. Campbell is a suburb of San Jose. Born in Schenectady. So I know all about the kind of weather you had. That's why I live in California now for 4 decades. Got my double E at Case in Ohio. That was a beautiful 4 years in the ice and snow. But I retired now a couple years ago after working for several high-tech companies there you see on the screen, plus some startups. We got 5 grown kids, 6 grandkids. I'm a bogey golfer. I love to hike. I love to perform and play music. But my geeky passion, and I call myself geek proudly, is Parks on the Air. I discovered it about 4 or 5 years ago. Over 900 activations. Should hit 1,000 maybe next year. We'll find out. Over 70,000 sideband QSOs. The last time I did CW is when I passed my extra in the 90s, did 20 words per minute. I haven't used it since. I probably should. You can take notes if you want. You don't have to. All the content that I'll be skimming over quickly tonight is at these Cloud Drive links. Each one is a PDF. They're all free. I always do everything for free. But if you ever want to get on my email geek list, you'll be the first to hear about any updates to any of these antennas, as well as new antennas that I do. And I update my antennas almost weekly, my PDF. So by all means, if you haven't downloaded one of these recently, you may want to check it out. I'll be talking about all of these very briefly tonight. So let's get started. I am a geek. But when it comes to antennas and ham radio, I try to be very pragmatic. I spend about 5% of my development time in math and physics, but I found 4NEC2 about 4 years ago, learned how to use it effectively so I could understand how to start antennas. When I first started POTA, I didn't want to buy my antenna. I wanted to build it. So that's what gave birth to my first antenna, the Performer, which we'll talk about. But I really enjoy doing that. In Silicon Valley, unlike in New Hampshire, we live on postage stamps. So I use my backyard pictured there. Not big, but it's there. But that's where I do a lot of my antenna testing. But the real world evaluation comes in POTA parks. And that's why I love doing POTA, because I can try out new antennas and get some real world feedback from hunters all over the country, all over the world. It's fantastic. Like a good engineer, I have 3 priorities, 3 design principles. First and foremost, performance. I only design antennas that are 90% efficient or more, meaning you put 90 watts in, you get 100 watts radiated out, proved and confirmed by the model. Every antenna is resonant. I don't believe in using tuners. 1 band at a time, because then it has a predictable radiation pattern and efficiency, and I like that. Second principle, elegance. Like Apple, I like something that's very complex under the cover, but fast and simple deployment, elegantly put together, set up and take down 5 minutes or less. Nowadays, I can do things in 2 minutes, even less than that, depending on the antenna and the conditions. And of course, being a portable antenna emphasis, it's got to be very convenient, got to be easy to pack and transport in a backpack, on a picnic table. And one thing I didn't realize when I first started, especially here in California, we don't have as many HOAs around here, but about a third of my antennas that I have, as far as I know, I have at least 2,000 folks out there using these antennas. About a third of them are all in HOAs. And they like to do fast setup and take down, so they're The guardians of the neighborhood don't see them. So that's a lot of fun for me. So performance, elegance, convenience. I am going to talk a little bit about the technology, the theory behind it, but I'll keep it very high level, just enough to keep you understanding of why I designed the antennas I did. So let's take a look at radiation resistance and loss resistance. Some of you may know this, but I'm surprised how many hams don't. So let me get into it. If you look at the top, you see the equation we all learned when we passed our exam. Impedance equals real resistance plus the square root of -1, which is J, imaginary number, times the reactance, which is either inductive or capacitive. But let's assume we have a resonant antenna. When you have a resonant antenna, you can model it as basically here's your source, your TX source, and it's two resistors in series to ground. That's your resonant antenna. And as most things in life, you have a good resistor called radiation resistance and a bad resistor called loss resistance. Radiation resistance is the good resistor because that helps you radiate electromagnetic waves in all directions. That is productive energy. The bad resistor, well, that's conductive RF resistance, any kind of losses in your components, but most importantly, it's losses in the ground and ground absorption. And this is where most hams lose a lot of their potential radiated energy into the ground. And how do we measure efficiency? It's a long evolved formula, but in the end, it's real simple. You take your good resistor, which is radiation resistance, and over here you can see, for example, in a typical quarter wave, it's about roughly 37 ohms. A dipole horizontal fed at the middle is about 70 ohms. So in this case, if you got a vertical antenna, it's 37 ohms over 37 ohms plus your loss resistance. So looking at that equation, what do you want to do? You want to minimize your radiation loss or loss resistance, and you want to maximize your radiation resistance. And that's what gives you your efficiency. So when I say 90%, that means this number over that sum is at least 90% or better. Okay, pretty straightforward. You don't want to waste energy. Now, this is the chart. There's a lot of complexity behind it, but I tried to simplify it, make it very visual. And this sometimes shocks some people. So let me get right into it. There was a very smart man, a lot smarter than I am, John Oppenheimer, about 10 years ago, who did some rigorous calculations and testing, and he figured out what the loss resistance is for radials on the ground, which is the way most of you use your vertical antennas, I think. You use radials, you use those Faraday cloths, you put things on the ground. You shouldn't do that, and I'll tell you why. He actually measured the loss resistance from 2 to 60 radials, and he came up with some amazing numbers, which when I first saw this 5 years ago, I literally was shocked. Let's suppose you have a vertical antenna with 2 radials laying on the ground. Okay, that's the minimum. That's 85 ohms loss resistance. Now, 85 ohms doesn't sound very much, does it? It sounds like, well, that's nothing, right? But put it into your efficiency equation. When you use a quarter wave vertical, the inherent radiation resistance is around 37 ohms. 37 over 37 plus 85, that's 30% efficiency. So if you only have 2 radials on the ground, you put in 100 watts, you get 30 watts transmitted. I don't care. You may have perfect SWR. You're going to make contacts, but you're only radiating 30 watts. That's not efficient. Okay, but don't worry about that. I use 4 radials when I go out and do parks on the air. Well, 4 radials isn't much better. It's 63 ohms. You plug it in the equation, you get 37%. All the way down, it takes at least 32 radials, which is typically the inflection point in most of these curves, to get at least 70% efficiency. 32 radials, and not too portable. But it works well at home, 32, 64. I know a lot of guys do that. But it takes at least 32 to get 70% efficiency. To give you some perspective and why I got so excited about elevating radials, I have modeled and I have measured in the field when I elevate 2 radials, at least roughly 2 to 3 feet off the ground, my radiation loss is only 4 ohms. What is my efficiency? 37 over 41, 90%. This is why you want to elevate radials. Don't cheat yourself. Don't warm up the ground. You'll still get a great SWR. You'll still make contacts, but you can make even more if you elevate those radials. There was another smart man. That was Rudy. He did this a few years before John. November 6th, Lima Fox. He had done a lot of QST articles. Brilliant guy. Back in 2010, and this was in QST, you may have seen this, he did an interesting analysis, which I think started a lot of this discussion more recently. You look at this chart here. This is the x-axis. The x-axis is the number of radials, and he went from 4 to 64. The y-axis is gain improvement. He took some field intensity measurements about a wavelength away, and he called that baseline with 4 radials on the ground, on 40 meters with a choke isolated. He called that his normalization point. So he said, okay, here's 0 dB. We'll call that 4 radials lying on the ground. And then he began to add radials, 4, 8, 16, 32, 64. And what he found is you get this beautiful, nice little curve. And by the time he got to 64, and that's a lot of long radials on the ground, he got almost 6 dB or an S unit gain improvement field intensity about a wavelength away. That sounds pretty good, and it makes a lot of sense. Then he got the idea, and so let's change up the chart a little bit. The y-axis is still gain improvement, all right, normalized to 4 radials on the ground. The x-axis is, I'm just going to keep it at 4 radials, and instead of adding more ground radials, I'm just going to start raising those 4 radials off the ground. Remarkably, just 6 inches off the ground, he got 5 dB improvement, field intensity, all the way up to close to 6 dB when he was 4 feet off the ground. If those of you remember in high school physics class, a capacitor, you got 2 plates. As you move the plates further apart, the capacitance, which is not your friend in this case, is inversely proportional to the distance. So if they're on the ground and you've got a lot of current in your radials, that's going to couple to the ground and you're going to heat up the ground. But when you start moving it off the ground, the capacitance goes way down, the capacitive coupling goes way down, and therefore you get more potential radiated energy. And that's why this works so well. So let's take a look at a resonant antenna. A resonant antenna, and I think you all know this, it was on the test when you got your license. You get a standing wave where current and voltage are 90 degrees out of phase. Current looks just like this in the red, and voltage looks like that in the blue. And you all know, if you remember, where's the current maximum on a half-wave antenna? It's at the center. If it's a dipole, that's where your 73 ohm impedance is. If it's a quarter wave vertical, you take this end and you move it up here, and that also becomes your current maxima. Where is the voltage maximum? It's at the ends. Hence, that's why you get your voltage here and your current there. So what happens as you move down the half-wave antenna? Well, if it's off-center fed, you can see your voltage increases significantly, but your current goes way down. And especially with an end-fed half-wave, you got very negligible current at the end of your antenna, and especially in your counterpoise. So why is it so important to elevate the radials in a quarter-wave antenna? Because when this piece is up here and you got your current maximum here at the feed point, when I see a quarter wave antenna with the feed point on the ground with ground radials, this is your current maxima. All the current is at that point, and even your feed point, and especially the first half of your radials, has got a lot of current in them, and all that current is being coupled into the ground. That's why you want to elevate your radials, because current is what radiates, not the voltage in this case. Okay, so negligible current when you run it as a half wave in your counterpoise in particular. So it's okay to have your counterpoise and a half wave on the ground. Not okay if you want efficiency to have your quarter wave radials on the ground. I know I went through that fast, but I'm trying to get to the good stuff. So that inspired my very first antenna design called the Performer, and I know a few of you have written to me about it, so you know it. But it comes in 3 flavors, and we'll take a look at those. The Performer stands for portable, elevated, resonant. It's a quarter wave vertical antenna with an elevated feed point, because where's the current maxima? Right here or right here. You want to keep it off the ground, at least a foot. I like 4 to 5 feet in my particular case. This is my backyard, by the way, and this was taken during the summer. You can tell it's a little bit greener back then. The feed point's 4 to 5 feet off the ground, and it has 2 elevated, tuned, linked radials. What does that mean? Elevated, off the ground. Tuned means when you elevate radials off the ground, they have to be tuned to the band. When they're on the ground, you don't have to do that. It's not as important. But when they're elevated off the ground, it's the other half of the antenna, so it has to be tuned to that particular band. Linked means that it's a multi-band antenna, but it's one band at a time. But I put links in the radial lengths so you can lengthen them and shorten them for that particular band. That's what it means. I did tons of computer modeling back in the day, and I found that if you take two radials and you keep them 90 degrees apart, and I tested 20 all the way up to 120 degrees. I tested 2 radials, 6 radials, 4, all of the above. The optimal case and the balance between performance and convenience was 2 elevated radials, 90 degrees apart, makes this thing directional. And we'll talk about that in just a moment. As I said, I did computer model it. It's highly resonant on each of the bands, one band at a time, and it's designed to be very lightweight and easy to deploy. And I put these at picnic tables. I put these in my backpack, and I'll show you how I did that. So let's take a look at.
Just a quick question. Are you going to talk about how invariant they are to basically operating CW versus SSB in a particular band?
Yeah, you can use them both ways. This thing is so broad-banded, and I think that was Pete. Yeah, you can use it. In fact, I'd say easily a third of the folks that use these antennas, they fluctuate between the digital side or the CW side of the band and the sideband. And I'll explain how I do that in just a second.
Okay,
So when you look at the pictorial of the antenna, and I'm sorry I'm going fast. I just want to make sure I cover everything, but I'll take a pause later for questions. When you look at the antenna, here's basically the picture of it. Your variable tuning element, and this is to answer Pete's question, from the top of the band for sideband or bottom of the band for CW or digital, is your variable. And that's what tunes, and that helps you get around not only where you want to be in the band, but also if different soil conditions, ground conditions, near field surroundings, it's a different length of whip, even on 20 meters for every location I go to slightly. So that's your variable. That's your tuning variable. But what's fixed is the length of the radial. And to answer Pete's question, what I did, because this is the other half of the antenna, right? This is your half wave. Here's half. Here's your current maxima. Here's the other half of the antenna, and it's all above the ground, so it's not coupling, and you're not losing your radiation into the ground. The other half of the antenna, each of these segments indicate the other half of that particular band. So for 6 meters, in this case, I use a Muller clip because I love Muller clips. I just clip it onto a mirror mount. You got to have a choke. I'll emphasize that. You got to have a choke because you don't want the shield of your coax to be a third radial or to generate common mode currents or RFI. So you got to have a choke. That's about 1.5 inches. So I just build that in. 41.5 inches is your first segment for 6 meters. So basically, this thing is roughly about 45, 47 inches. Your radial, quarter wave radial, is roughly about 43 inches. And bingo, you get an elevated 6 meter vertical. 10 meters, you add another 37 inches. What is that? About 80 inches total, etc. for each one of the bands. So instead of running a completely different set of radials for each of the band, I just increment the length of the radial for the next band. And if you look at each of those, I use spade connectors. You can use whatever you want, but it's a really convenient way to extend the length of the radial. But it's tuned to the center of the band, Pete. The radial is tuned to the center of the band, and then you can move the whip longer for CW digital or slightly shorter for sideband. That's how you get the band coverage. And I'll show you the SWR charts in a minute. Now, there's 2 ways to change the length of these radials. One is you just, like, let's say you want to work on 10 meters. You just have the 2 segments on, you unclip this, you move this up, and you can move the fiberglass stakes in. These got to be non-conductive, of course. You move them in, and you got your radial set. You adjust your whip, and you're done. But there's a better way to do it. The better way is, instead of moving these stakes back and forth, let's keep all the links in each of the radial lines 90 degrees apart. But how do we kind of block the rest of these segments from these 2 segments? Let's create these non-conductive segments with spade connectors on each end. And when I go out to the field, they're typically here. If I want to go on 10 meters, I pull them off of here and I move them here. So at this point, the antenna only sees the 6 meter and 10 meter segment. Then it sees a non-conductive segment. I use paracord. A lot of guys use the weed whackers. You can use whatever you want in your radial line. But the antenna never sees the rest of the segments. So once you set it up with your 2 radials elevated 90 degrees apart, you can just keep the stakes where they are and just keep moving your non-conductive segments in between the bands you want. So in this case, I got it right in here between the 10 and the 12. The antenna only sees the 6 and the 10, and it doesn't see the rest of it. And yet the whole thing is still elevated, so you're not losing any of the your potential radiated power into the ground. Does that make sense? Okay, good. Now, there's two ways, well, actually three ways to deploy it, but two primary ways. If you don't have a good tripod, strong recommendation for the Polar Duck tripod on Amazon. I provide the complete parts list with links in all of my PDFs, so you'll find it there. This thing is a 78-inch Polar Duck tripod. This is the old version where I put a tube in. Nowadays, they have a nice black telescoping pole, so it's very convenient. But what makes it fantastic, it's extremely lightweight. The legs are telescoping, and there's no center plate. So you can move these legs completely flat if you want to. If it's really, really windy, or if the ground is uneven, you just shorten one of these legs. It's an amazing tripod. I really like it. So here's the tripod deployment. And here's the mirror mount that I talked about. There's the Muller clip. You can see I put both radial pairs. They come into one Muller clip, which is just clipped to one of the screws, in this case on the mirror mount. And the other radial, I have another Muller clip on each one of the radials and is hooked to this non-conductive segment. And you got to make sure it's a non-conductive segment. I use these tomato stakes. I know back east, you guys must have those driveway markers, bright orange. I even bought some of those because they're so visible. As long as there's no metal in them, you're fine. Okay. The way that I like to deploy, if the ground is suitable for it, is what I call the PVC spike. Because I like the PVC because the whole PVC, unlike a tripod, the PVC is not conductive. I've noticed in some cases the aluminum legs of the tripod can interfere a little bit if you're 6 meter and 10 meter short radials, not so much on the other bands, but I really like the PVC tube. I use furniture grade, not irrigation pipe, because the walls are a little bit cleaner, thicker. The outer surface doesn't have all that nasty writing on it. I use a chameleon spike and I punch it in the ground and I'm ready to go. Alternatively, you can use the WRC Megapod or something equivalent if you don't want to spike it in the ground, or if you got snow on the ground, or if the ground is frozen, or if the ground is rocky. At the base of the PVC tube, I just got a 3/8 by 24 bolt, which screws into the tripod or the spike. At the top of the tube, I have a coupling nut. I glue it all together. Then in the top of the coupling nut, I just put a threaded short aluminum rod with a mirror mount. I already have the choke. This is the Palomar choke already attached. And all I have to do is go out in the field, stick this in the ground or put it on the tripod, put in the whip and in the radials, and I'm ready to go. It's fantastic. These are all my radial segments. You can see I have them all with these spade connectors. If you don't have a good spade connector kit, again, another recommendation, and I don't get any commission from these. I'm just giving you all my favorites. It's called Wirefy, also available on Amazon. A great crimping tool, but I love their spade connectors because not only do they have heat shrink tubing, they have internal glue. So the thing stays on the wire incredibly strong. You can tighten them up if you have to with a pair of pliers, but I love these things. I've had them in the field for years and never had any issues with them. I mentioned earlier, I use non-conductive segments. I use 4 inches. Some guys go as short as 2 inches, at least 2 inches. So you keep the radial line interrupted at that point, and that terminates it at that particular band. I then wrap everything up with a little piece of Velcro. You got to label your segments because you don't want to get them mixed up, and you got to put them in order. That's very important. And then I put the whole thing in this zippered clear plastic bag commonly used for travel toiletries. This is great for POTA. I love this. And you can see I have a Sporty 40 in there for 40 meters. I recently bought the Chameleon 40 meter coil, which I actually like better. It resonates just a little higher than the Sporty 40, but it's a half the size and half the weight. So I'm using that from now on. I really, really like it. There is a portable version because I said I left a backpack and I got a ICOM 705. And so I throw it in my backpack. Slightly narrower PVC tube. You can see I cut it in half, put a coupler on the bottom. It's got the coupling nut on the top and the bolt on the bottom. I put a Velcro around it with a slightly shorter fiberglass stakes. The whole antenna still works exceptionally well, even though the stakes are a little bit lower, but it's great in a backpack. In my ICOM backpack, I put the linked radials in the toiletry bag. I love my Rig Expert stick. My Sporty 40 or now the Chameleon 40 meter coil. And I'm a big fan of Messi and Poloni Airborne 5 coax. It's the best, lightest, most highly efficient coax on the market. Strong recommendation for that. And here it is. The whole thing is incredibly light. Here's everything in the back. You can't see it necessarily, but I got the WRC Megapod sitting behind this. So if I can't put it in the rocky soil or something like that, I just use that. And the whole thing goes up and I'm all set up when I go up into the mountains for QRP. Computer modeling, extensive. These are all the specs. These are all in the PDF. You can look at them in more detail if you want later. But on average, the antenna efficiency across all the bands, over 90%, SWR extremely low, reflection coefficient, anything under minus 20 dB is phenomenal. This is fantastic. The gain, when you put the radials 90 degrees apart, it actually has gain in front to back, gain of about 4.41 dBi. The dBi, the I stands for isotropic. That's a theoretical antenna that radiates equal in all directions. This is 0.41 dBi, which is very good for a quarter wave vertical. It's got a takeoff angle or peak radiation angle of 24 degrees, which isn't bad for a quarter wave. And if those of you familiar with beams, there's something called a minus 3 dB beam width. That's where the power goes down 3 dB from the takeoff angle. And that's 44 degrees. The smaller that number, the better. That's pretty darn good because that then gives you a beam width from 9 degrees over the ground to 54 minus 3 dB beam width. So that's very, very good. The model produces beautiful charts, and this is why I love 4NEC3, or 2 in this case. Look at this beautiful chart. This is the side view. You can see the radial. Actually, you can see the two radials here. You can see them go off at 90 degrees. The peak, that little purple edge, if you can see it on your screen, that's the peak radiation, but you can see this half of the antenna provides most of the power. It's 3 dB, more than 3 dB front to back. Pretty darn good with a big dip right there in the center. And if you look over here, there's even some energy here, which gives you great regional coverage, as well as some NVIS for emergency communications. And I got a lot of ECOMS guys using this antenna as well. The model, of course, produces this beautiful looking directional vertical curve. You can see, notice all the energy up here that can go to the regional or NVIS, as well as the takeoff angle at 24 degrees. And of course, produces this beautiful, very broad SWR curve with a very high reflection coefficient. This happens to be the 15-meter curve. But here's the reality. Here's the reality. And Pete, and if you look at this, I'm an SSB guy. So I kind of tuned these. These were at a park, and so I had them tuned for the sideband portion. But if you can just shorten or lengthen the whip just a little bit, you can get a little bit lower. But the most important thing is look at the broad bandwidth. The entire 20-meter band is 1.5 or better. And let me emphasize that 1.5 to 1, 1.5 to 1 SWR. It's 96% efficient. Please don't use a tuner if you get a 1.5 to 1 or better SWR. You don't need it. You're 96% efficient. Most 99% of the antennas out there aren't even that good. So at 1.5 to 1, don't get anal about it. It's beautiful. Leave it as is. Don't put a tuner in there to suck up some of the potential energy as well. So if you look at this, that's very broad on 20 meters. Of course, the 17-meter band completely under 1.1. Here's the entire 15-meter band, basically 1.2 to 1 or better. The very narrow 12-meter band, of course, very low, very flat. 10-meter band, you get about 2/3 of it, 1.5 or better. If you want to do some FM, you just kind of shorten the whip a little bit, and it looks the same curve. It's basically up here. And of course, the 6-meter band, you get most of the band, half the band, 1.5 or better. I typically operate down here on the calling frequency when the band is open. It's fun. Also, the FM frequency, you just adjust the whip. Any questions on the performer before I jump into a couple more charts? Pete, did that answer your question from way back? Yes, he says.
Yes. Thank you.
Yeah. Okay. Just wanted to make sure. I know I'm going fast. I apologize. Now let's take a look. Now, not everyone wants a directional vertical, right? A lot of the guys that use my antenna in the Midwest, sometimes they want to work a certain part of the country, some states they don't have. Other times they just want to be omnidirectional. So if you put the radials 90 degrees apart, they're directional. That's the red. This is the computer model. That's the red outline, side view. Omnidirectional, you just put them 180 degrees apart, opposite each other. And that's your very typical, you can see very typical omnidirectional vertical curve. Let's zoom in on that a little bit more. The takeoff angle, 24 degrees. When you got the 90-degree span, you get that. This is on 15 meters, 0.31 dBi. 180 degrees, it's minus 0.67 all around. So there's about a dB difference at the takeoff angle. For those of you that aren't familiar, anything between 30 and 60 degrees is great regional coverage, fantastic for POTA. That's why this antenna is so popular. Look at the extra in the directional version, 90 degrees apart. You get all this extra power in the regional view. That gets you out to about 1,000 miles. So it's great to work a part of the country that you want to work on. Or NVIS. And look at all this extra energy. I mean, it's not significant. It's still down. It's between -3 and -6 dB, but still, that's enough energy compared to the omnidirectional, which basically gives you nothing in an NVIS. So that's why this antenna is so popular, because it gives you a good takeoff angle. You've got energy here for DX, and I've gotten DX on this off the forward. But off the rear, of course, you get a minus, in this case, -3 dBi front to back. And whereas the vertical, of course, omnidirectional gives you more energy. But it's your choice. If you want to go directional, if you want to go omnidirectional, it's your choice. And that's the difference in terms of the antenna patterns. Any questions on that? I'm making good progress. It's only 20 to 5, so I got a half hour left, so I'm doing good. I can slow down a little bit. And again, I apologize for going fast. All right, that's the quarter wave. So that's my favorite quarter wave antenna. I was on it today. I made 140 contacts, 140 of which, and I checked before I got on, 64% were in the Northeast from California. 64% of 140 sideband QSOs were in Maine, Vermont. A guy was mobile in Vermont. He was shocked he could hear me. New Hampshire, Lawton, Jersey, Massachusetts, Maryland, Virginia, a lot in Florida. I was working the Eastern Seaboard. Of course, the gray line helps.
Greg, I have a question.
Yes, sir.
So with that antenna, with current prices off Amazon, if you're just take a guess, how much money do you have into that?
Okay, we're going back to the Performer.
Yes.
Yeah. Well, see, here's the thing. What I do in my PDF is I give you all the best possible components, right? The chameleon whip, very expensive, 17-foot. Mirror mounts and that sort of thing are pretty inexpensive. I have really good coax. The radials, I use a BN Tech Go wire, orange wire. I don't know. I'd say under $100, under $100. But a lot of guys already have a 17-foot whip, so that's the most expensive part of the antenna. There's a choke in there on a quarter wave. That costs about $30 from Palomar, but a lot of guys use beads. That's fine. If you use beads, minimum 3, 5 is better, 7 is the best. If you're going to use beads on your coax, 3 minimum, 5 is fine, 7 is best. You already probably have those. So a lot of guys build this antenna out of spare parts, stuff that they have. They make tweaks. If you want to build it the way I do, it's about $100. If you want to build it off of stuff out of your ham radio box, it's probably a fraction of that. So it's a relatively inexpensive antenna. You don't need to pay hundreds of dollars for an antenna, folks. You really don't. Okay, let's talk about, that was a quarter wave antenna. Let's talk about, I have a couple of half wave antennas. I have an off center fed and an end fed. Let me talk about those. And again, these are all portable. In California, they don't allow us to put wires in trees. So that's why all my antennas feature a telescoping whip. I also prefer a telescoping whip because it's a variable tuning device. That's why I love it. Infinitely variable tuning device. That's why I like it. And I have preset radials for the quarter wave and a preset counterpoise for the half wave. Let's take a look at this. Now, you remember back in the beginning of the presentation, I showed you that chart about ground loss per number of radials, and that's what this number represents over here. And here's the efficiency from, if there's one radial, 104 ohms of ground loss, that's 26% efficient, all the way down to 120 radials on the ground, 98% efficient. Now, a counterpoise on a half-wave antenna is not 104 ohms. I guarantee you that. But for the sake of math, I wanted to show you, let's call it a mathematical exercise, that I said you can do one of two things. You can minimize your loss resistance, which is this number here, radials, or in this case, counterpoise on the ground, or maximize your radiation resistance. As I mentioned, I don't think I mentioned in that particular slide, but a half-wave antenna has a much higher radiation resistance than a quarter wave. It's in the hundreds if you're off-center fed. It's in the thousands if it's end-fed. So let's just take that 104 ohms, worst case, one radial on the ground, plug it in the radiation efficiency equation, and see what the results are. Again, this is not real world, but it's a mathematical exercise only to make a point. And that is, here's your quarter wave. 104 is a big number compared to 37, so it's 26%. But as the radiation resistance increases for a half wave, it becomes less and less significant. Just taking this ridiculous number of 140 ohms, 200 ohm typical 4-to-1 off-center fed half wave, 66% efficient. End-fed half wave, another reason why they're so popular, a very high radiation resistance. You get at least 96% efficient. Again, mathematical exercise only. In the real world, my modeling and field testing, a single counterpoise wire on the ground ranges from 12 to 25 ohms. Hence, you get significant, just replace 104 with 12 to 25, you get significant radiation efficiency. It's fantastic. And why? Remember going back, why can you lay your counterpoise on the ground? Because you have very little or negligible current in the counterpoise, so you don't have to worry about it coupling to the ground and losing radiation. Make sense? Okay, let's get into the antennas. I have two types of antennas. I have, and again, notice for this polar duct tripod, I show you two examples of the new one now. This has got the telescoping tube, which goes up to 100, goes up to 78 inches, which is way too high for these antennas. You can't reach the whip at that point. But here's the 4-to-1 UNUN on the off-center fed vertical. Here's the 49-to-1 UNUN or transformer on the half-wave vertical. And you can see in this case, I have shorter legs and a longer pole here. In this case,
Wow.
I have very broad legs and a short pole here. It makes no difference. You can do it either way. Was that a question or just a noise? Just a noise. Okay. The reason I love this tripod because it folds up so tiny. And what I do is I already pre-mount the mirror mount and in this case, the UNUN, whether it's 4-to-1 or 49-to-1, already on the tripod. I just use one of the 4 screws and I mount it. So this is ready to go. You can see you have a pigtail from the positive side of the UNUN to the underneath the whip and another pigtail for the counterpoise that you hook on over there. And this thing is all ready to go. It fits in a little 36-inch photography bag. It's so light and so easy to carry out to a picnic table in this case. So let's take a look at the picture. Again, your variable is your telescoping whip. That's your variable. That's how you tune it for each of the bands within a band, as well as depending on the soil conditions and the near field surroundings. Again, like the quarter wave, I use a mirror mount, except in this case, I have a bolt at the bottom instead of an SO239 with a ring terminal. I hook it to, in this case, the positive side of the UNUN. This is an LDG. This is the cheap UNUN. This is if you want to get into it basic, you can use it. I've got a much better one that I'll recommend in a moment. The whole thing sits on a tripod. The nice thing about it is because you don't have as much current in your feed point, unlike a quarter wave. Remember I said it's important in a quarter wave to have it about 4 feet up. You can have this as little as 1 foot off the ground. I would not go lower than that. But for a half wave, have your transformer at least, or UNUN in this case, at least a foot off the ground. I like to go about 48 inches. Again, like the quarter wave, you have to have a choke because you got to isolate the shield. You don't want it to be a second counterpoise and give you very bizarre radiation patterns and, of course, common mode currents. And then I already have a 6-inch pigtail ready to go, which I then have a counterpoise, which I can hook onto that for the particular band of interest. And like the two radials in the Performer, the one counterpoise is a link counterpoise, one segment for each of the bands, and it droops down off the side of the tripod and eventually touches the ground where there's very little or negligible current. So there's no problem with that. The half wave, end-fed half wave, is identical, except with a 4-to-1 unun, you use a 49-to-1 unun, or you may call it a transformer. Same thing. It's basically built the same way. And of course, it matches the end-fed half wave impedance at the end of the antenna. This antenna, I love this antenna. This is my newest antenna. It operates as a half wave, off-center fed half wave from 20 meters all the way up to 6 meters using a Chameleon 25-foot whip. So yes, you have to find one that's in stock. I think Gigaparts has them, but they cost $100. I know they're not cheap, but they're built so well. I love them. The Dominator half wave, because it's an end-fed half wave, the whip isn't quite tall enough for 20 meters, so it resonates as an end-fed half wave, vertical end-fed half wave on 17 to 10 with extremely low takeoff angle, which I'll talk about in just a moment. And I'm also waiting. Chameleon says they're coming out with a top hat for their telescoping whips. That's very lightweight and won't let them sag. I'm waiting for that. If that's the case, then I can up this to 20 meters, and that would be very cool. We'll have to wait and see on that. As I mentioned before, in each of the documents, you don't have to take notes. I give very specific measurements. You can see each of these are linked with incremental segments for each of the bands. Yes, you can use the same non-conductive segment that you used on the Performer radials. You can put one on the counterpoise, so you don't have to, you can leave all your wire on the ground and just keep moving that simple little non-conductive segment wherever you need it and adjusting the whip. That's how I change bands really, really quickly. You can see the close-up on the off-center fed. Here's the LDG unun. You can see I took one of the screws on the mirror mount, put a little spacer there, mounted it so it's a little bit away from the telescoping tube. There's your 12-inch pigtail off the positive side of the unun. That adds 12 inches to the radiator. So you have a free foot that's there. There's not much current, so it's okay to do that. And then on the other side, here's your 6-inch pigtail that you hook your counterpoise wire onto. The same thing with the 49-to-1. Here's it again, already mounted onto the mirror mount. There's the pigtail, and then here's the pigtail for the counterpoise on the other side. Pretty straightforward, right? I hope. Now let's talk about the components, and this is the part that I think is the most important. So I want to spend a little bit more time on this. There's a lot of different components you can use, and I gave prices, Ryan, so at least you have an idea of what you're getting into one way or the other. And there's basically a Challenger, which is basically the entry-level components. If you don't have these things, it'll cost you $30 for the LDG unun, which is rated at 200 watts, which is good. They only go up to 30 megahertz, but I found it works well on 6 meters when the band's open, so you can use it there. Then my favorite Palomar coax wrap toroid only costs about $30. So you can get the off-center fed components, impedance matching components, for about $30 or $60 total. You only lose about 0.46 dB. I took my nano VNA and measured this many times to get insertion loss, a little over a third of a dB on the unun, and about 0.12 negligible on the toroid. However, if you're a geek like me and you want absolute best performance, let's up it a little bit. That's the Challenger. Let's call this the Challenger Plus. And I'm a big Palomar engineer fan. They're based in San Diego. Strong recommendation for this company. The insertion loss is an incredibly good minus 0.24 dB. Look at that, 94.6% efficiency. Very broadband. In the real world, when I use this versus this, I get much broadbanded, better SWR than I do with that one. This works, but this is by far better for a little more than twice the price. And it uses a dual port ferrite bead, and I'll show you that picture in just a moment. They also have a better choke, rated at 500 watts. Noise reduction, this goes down to about 32 dB noise reduction, which is very good. Anything below 20, minus 20 is great. This goes down to minus 42 dB. So it's very great isolation choke. And you put these two components together, it's only minus 0.3 dB loss, insertion loss with those two together. Now, These two cost you 60. These two cost you 140. I know guys that take this one because this is the most important component and 70 and match it with this one. So that's 30. So you have 60, you have 100, or you have 140. It's your choice. You have 3 flavors of the Challenger. I use this one because I'm a geek. You don't have to. Use whatever you want. The Dominator, now this is the one that always surprises people because I don't know how many people realize how inefficient a 49-to-1 toroid is. Inefficient, not efficient. I don't care how well they're made, it's not efficient. One of my favorite 49s to 1s is on eBay from 10 Tennis, made by a great guy in Tennessee. He's done an excellent job, and I'll show you a picture of the inside of that in just a second. But it's got close to a dB of insertion loss, or that's 80% efficiency. So you're already losing 20 watts just inside the transformer. Not great, but it's really as good as many of these types of 49-to-1 transformers are. I mean, you can build your own and get it up to mid to upper 80s. I've seen some guy on YouTube claim he's got 90%, but you know, that's a special toroid, a lot of different kind of winding. And I'm not even sure if that's a 49-to-1, but he's got about a dB loss in his toroid, and you match it with the same Palomar and you get your 45-30. So you lose a little over dB for $75. But like I did with a Challenger, guess what? I have a Dominator Plus. I love my antennas. I mentioned Palomar is one of my favorite companies. Myantennas.com is my other favorite company. Go to their 56-to-1. They got this amazing for double the price, but check this out. The insertion loss is minus 0.4. Minus 0.4. That means this transformer, it's a 56-to-1, so you need less counterpoise, right? Because you're closer to the end of the antenna. It's 91.2% efficient. That's remarkable. This is what I use at home on my little postage stamp lot for my sloper. This works incredibly well. It's been outside for years and I love it. Very broadbanded, but like most 49 or 56-to-1 transformers, you can't get 6 meters on it. That's just the way it is. It's the mix that's built into the transformer. However, you can match it with the same Palomar choke, and you get this very efficient. You only lose about 0.51 dB between the two. This is what I use in the field. I use the Dominator Plus and the Challenger Plus. But again, just like this other one, you can take this one and match it with that and save yourself $40. I know a lot of guys do that. But I'm a geek. I go for the maximum stuff. Let's go inside. I said I was a geek. I like to look at these things. The LDG uses a very simple 140 by 43 toroid. The 140 means 1.4 inches in diameter. The 43 means it's a mixed 43, which is what you use for HF. 20, typically 40 to 6 meters, more like 10 meters. That's typical. It's only about a ½ inch thick. So that's why it's entry level, right? However, the Challenger Plus, Palomar takes a completely different approach. Instead of a toroid, they use a dual port ferrite bead that's 1 1/8 inches tall and wide. It's a very big, fat toroid. It's dual port, so they wrap the wire within it. It's phenomenal, and you can see all this goop that's in there to keep it in place. It works really well. And the really good choke is basically the same sort of thing, except they use a ferrite bead. Notice this is mix 31 when you use chokes. When you have a unknown, you use a mix 43 for HF. When you have a choke, you use a mix 31 for the choke because you want to choke off those other frequencies. But notice it's also 1 1/8 inches tall. It's a beautifully well-made choke. Here's the 10 tennas I talked about. The guy hand makes them down in Tennessee. He does a beautiful job. I mean, he does. Look at this beautiful workmanship. And he uses a 240 by 43. So it's 2.4 inches outside diameter with a 1.4 inch inner diameter. So this whole thing can fit inside that hole there. I don't know if you can tell. But then let's go into the My Antennas. This thing is a work of art, geeky art. I love it. It's only 1.4 inches outer diameter, but look at the inner diameter, much, much smaller. But most importantly, look at the height. It's 1 inch thick. And if you work through the volume of toroids, which I did, it's equivalent, and this is what they say, but I verified it. It's equivalent to using 3 of those. What does that give you? It gives you higher power it gives you more power to be able to use through it. I think it's rated at what did I say it was rated at? I think it was rated at 250 watts. But the other most important thing is it's very broadbanded, and it gives you incredible bandwidth per band, and I'll show you how that works in a second. The Challenger Plus versus the Challenger using the Palomar Unun versus the LDG Unun, because it's a 4-to-1, it's still an off-center fed, and this is basically the same lengths. You can use the same counterpoise on either one. The Dominator Plus, because it uses a 56-to-1 versus 49, that means you're moving down the half wave a little bit further. It has a slightly shorter counterpoise. Here's a geeky picture of when I was testing them in my backyard, and I've taken this to the park pretty much the same way, but you can see the Dominator Plus on the left and the Challenger Plus on the right. This is the end-fed half-wave vertical. This is the off-center fed, and I just switched the pigtail from one to the other, and it moved the coax from one to the other. And you can use either one, but you don't do that in the field. Most people don't do that. I just did that for testing, but just to kind of show you what they look like. Now, there's another version, and this is actually works so well. I've been using this even at picnic table activations. Instead of the tripod, I take a pretty 1 1/4 inch outside diameter PVC tube, furniture grade, only 16 inches long. Remember, your feed point can be as low as 12 inches off the ground. I try to keep it around 2 feet off the ground. I capped it just like I did with the quarter wave PVC tube. There's the spike. There's a telescoping whip. Here's the Challenger Plus with the 2 Palomar units. Here's the Dominator Plus with the My antennas and the Palomar choke. And this is the whole antenna. You can see it mounted. Again, in my backyard, here's a Challenger Plus. Look how compact that is. Here's a Dominator Plus. And if you don't want to put it into the soil, you use a little megapod or some kind of small tripod, and it just sits on top of the ground with the same mount. And you can see there's a telescoping whip, there's a pigtail, and then there's the counterpoise. The whole darn thing fits in my ICOM 705 backpack. The side pocket has the spike. It also has the tripod kind of hidden behind here. But you can see there's the spacer, so there's a strap, so it fits really nice and neat in the little side pocket. You can take this up into the hills, and in this case, this is the Dominator Plus. You get some elevation with a very low takeoff angle, which I'll show you in a moment, and you get some amazing DX. That's why I love this antenna as well. So here's your portable backpack version. Lots of flexibility. The model spews out a lot of numbers. Bottom line, average across all the bands. The structural efficiency is 94%. Depending on which Unun you use, it's 92 to 94%. SWR average 1.04, great reflection coefficient. You got a peak radiation gain. This is an omnidirectional antenna, minus 0.7 dBi all around. Remember, the Performer had a 24-degree takeoff angle. This has 21 degrees, 3 degrees lower. This is the off-center fed half wave. The beam width, I think the Performer was around 48. This is 32 degrees, so you're concentrating more of your energy in a much smaller beam width, and you can see that. The Dominator, similar results, very high structural efficiency, but depending on which transformer you use, this is the 49-to-1 is 80%. The one I love, the 56-to-1 is 91%. That's why I love that so much. Great SWR and reflection coefficient across all the bands. Because it's a true half-wave vertical, you get a positive omnidirectional plus 0.67 dBi in all directions. And it's 3 degrees lower than the Challenger takeoff angle. So the Performer was 24. The Challenger was 21. This is 18 degrees, even lower for even better DX. And look at the beam width, 28 degrees. Here's the model. This is 15 meters on the Challenger. That's the off-center fed. Notice the radiation pattern looks a lot like a quarter wave vertical. Now keep your eye on this chart. When I switch to the end-fed half wave, there you go. It flattens out. And that's why a half wave gives you all that extra gain, because it kind of squeezes it down a little bit more compared to the quarter wave or even the off-center fed. And you can see the charts give exactly as expected an omnidirectional pattern. But here's the real world, folks. And check out, Pete, check out this SWR bandwidth. This is the Challenger. This is the off-center fed half wave. The entire 20-meter band is 1.1 or better. You don't need to tune it, whether you do CW digital or sideband. Same with a 17-meter band, The entire 15-meter band is under 1.2 to 1 SWR. Basically flat across 17. The entire 10-meter band is about 1.3 to 1 or better, and most of it, 2/3 of it, is under 1.2. And of course, the 6-meter band, 1.2 across the entire band for the most part. It's a phenomenal broadband antenna. That's the Challenger, the off-center fed half wave. The Dominator is no different, extremely broad on 20, 17, 15, 12, and 10. It's fantastic. So let's summarize things a little bit. The Performer gives you 40 meters, unlike the other two. The Challenger gives you 20 and 6, unlike the Dominator end-fed half wave. The peak radiation on the Performer is either omnidirectional minus 0.67 or directional plus 0.41, minus 0.27 on the Challenger omnidirectional, and plus 0.67 on the Dominator omnidirectional. And again, as I mentioned, the takeoff angle of peak radiation, 24, 3 less on the Challenger, 21, 3 less on the Dominator, 18. Beam width the same, goes from 46, concentrates down to 32, concentrates down to 28. So you can see why the Dominator, and I call it that for global domination, it's a great DX antenna. Very low takeoff angle, highly concentrated beam width. That's why it works so well. It's great for global coverage, whereas the Performer, a great POTA antenna, great for regional and continental. Here's a visual, graphical visualization to give you a better idea. Here's the Performer, 24 degrees. Here's your beam width. Here's the Challenger, 3 degrees less. Your beam width is 14 degrees narrower. And then you go to the Dominator. Not only do you get more gain, it's 3 degrees lower takeoff angle, even tighter beam width. And that's why I call it my DX antenna. When you look at all three antennas overlaid on each other, the Performer is in the omnidirectional form is in green, the Challenger is in red, and the Dominator end-fed half wave is in blue. And you can see, if we zoom in on it, you can see that the Dominator end-fed half wave, of course, at 18 degrees is your global DX antenna. At that same angle, the Challenger is minus 0.32, Performer is minus 0.1. So that's why, use the Dominator for your DX. But let's put the Performer in its directional position, and you can see already why the Performer is so popular, because it matches the Challenger at this level down here. Plus, you get regional and NVIS radiation as well. So it's very useful across many different applications. Let's zoom in. Comparing the gain, the Performer exceeds the Challenger at 16 degrees off the horizon, and it exceeds the Dominator at 23 degrees off the horizon. That's why this antenna is so popular. Of course, off the backside, it's not as good as the other two, but it's not supposed to be because it's directional. So to summarize, all three antennas are highly efficient, very fast deployment, easy to pack and transport. The Performer has 40 meters. It's the best antenna for 30 to 60 degree regional coverage. The Dominator, on the other hand, the end-fed, it's got the lowest angle of radiation at 18 degrees, strongest gain, and it's the best antenna for 5 to 20. But the reason I like the Challenger off-center fed so much, in the middle of all three antennas, it's got the highest radiation efficiency. It covers 20 and 6 meters, which a Dominator doesn't. And I call it the best antenna for balanced coverage. But wait, there's more. And then I'll leave you on this, and then we can have a few minutes of questions, and then I got to go, unfortunately. I decided, let's take the Dominator, let's turn it into a beast. Let's put a parasitic director, make it a 2-element vertical beam out in the field. This is a Dominator as is. I have a PDF on how to build this PVC support structure and put a second whip in front of it. And for those of you that understand beam antenna as a parasitic director, you don't have to feed it. There's no counterpoise on it. It's just a piece of metal, roughly 6% shorter than the radiator, that sits in front of it at a specified distance based on the band you're on. To accommodate the particular band spacing, this happens to be on 10 meters. You probably can't see, there's a little line there. I take a small tube and I put it inside of a bigger tube, and the whole thing stretches out like a trombone. So this is at 10 meters. When I go to 12, it's there, 15 is there, 17 is there, and from the side, you can see it's as simple as this. This is a Dominator antenna, in this case with the the 49-to-1. Here's the PVC tube. There's a little ring. It's at the end of the tube. So if you want to rotate the beam, you just pick this up and you move it around to whatever compass point you want. On this antenna from California, I worked park to park over the pole into Europe. I'll say that again. With this antenna and this configuration, I worked park to park with Europe from California over the pole. Why is it so effective? I'll show you in just a second. It's also very, very portable. The antenna fits in the same photography bag I talked about. And I designed the PVC structure so everything's glued except in two cases. This is the horizontal tube that rests. You can see there's the thing that rests on the mirror mount. There's the coupler for the second parasitic director. Here's the vertical piece that hooks from there down to the base in there. So in this case, because it's like this, it stores flat and it transports flat. It's really easy to bring to picnic table activations. But why is it so effective? Look at the 4NEC model. Look at this directional gain. You're talking about, I think I got close to 4 dBi on, I do, plus 4 dBi gain on this directional antenna. And you drop the peak radiation angle, the takeoff angle, 2 more degrees down to 16 degrees. The beam width even tightens down to 24 degrees. Front to back, 8.5 dB. This is a very efficient, very directional, 2-element vertical beam that's very portable, and I use it for POTA, and I love it. Extremely effective in the field, very flat, 17, 15, 12, and 10 meters. You don't need a tuner, one band at a time. It works fantastic. I do a lot of DX on 10, 12, and 15 with this antenna. I love it. So to summarize, here's the last column I just added. This is the Dominator. This gives you a lot more gain. It gives you 2 degrees lower takeoff angle and a tighter beam width of 24 degrees. So if you want to be added to my geek list, send me an email. It's good on QRZ. I always keep my PDFs updated for each of these antennas. I also pull a subset of all of these slides as a subset of my antenna primer, which is about 2 to 3 times bigger than the slides I sped through tonight, and I apologize for that. That's the end. And if you want to donate, you know, I take the money and I use it to buy antenna components because believe me, I had to buy about 10 different 4-to-1s to test them all. And in the end, I just promote the best ones that I found. So again, I apologize for that very fast presentation that normally goes an hour and a half or more. It's now 10 after 5 my time, which is my drop dead time, but I can take a couple of quick questions. I also take every morning over my 2 cups of dark Italian roast coffee, I answer emails. I get about a dozen a day. So if you have any questions, by all means, email them to me and I'll respond promptly the following morning. Any quick
Greg,
questions?
Quick question on the bands that you work. Do you have any bands that are dominant that is, you know, your go-to band across all these antennas? That's question 1. Question 2 is, what do you run at home?
Okay, so the bands, I spend the bulk, 80% of my time on 10 through 15. The only reason I do that now is because they're open. Those of us that have lived through the downside of a cycle know that at that point, only 20 to 40 is going to be open. So I'm relishing 10 to 15. I get great DX. I did a park-to-park with Chile this afternoon on my POTA Performer. Park to park with Chile from California. So 10 to 15 primarily. When I go on 20, the pileups are so big I can barely pull out a call sign. At home, living on a postage stamp, I use the My Antennas 56-to-1 as a sloper, going from my roof line on the first floor to a 40-foot fiberglass pole in the back corner of the lot. It works great for home use, but it's no beam like some of you guys have on your acres out there in New Hampshire.
Greg, quick question.
Yes, sir.
On your Challenger antenna, have you tried using a director on that?
No, you can't. It's not. You need to have a full half-wave antenna like on the Dominator. The
Okay.
Challenger, it won't work. I mean, I just for the fun of it, I tried one day. It's messy. I tried to model it. It's messy. So the only 2-element beam you can use is on the Dominator. And when they come out with their top hat for the 25-foot telescoping whip, you can get a 2-element on 20 meters. That would be way cool. I'm looking forward to that.
Cool. Thank you.
Any other quick questions?
Greg, I can just attest using the POTA Performer. I'm on my 3rd park activation now with it. It's phenomenal antenna. Twice now I've hit Hawaii from New Hampshire, and like they were sitting next to me. So great antenna, great design, a lot of fun to build too.
Oh, I'm so happy to hear that, John. That's why I do this stuff. And the reason you're one of the loudest signals on the band is because you have high radiation efficiency. A lot of guys can easily throw radials on the ground, get a great SWR, but you get a great SWR on a really bad antenna as well. So, I'm glad to hear that. That's fantastic. Any other quick questions before I go visit my Valentine and help her get ready for dinner? And you all have to go visit your Valentines too, I know. And I can see the two couple. I love the couple on the sofa. She's already asleep, but he's highly engaged. No, I'm just teasing. Don't worry about it. I know I went fast and I apologize. It never goes this fast, but I tried to do my best.
Greg, thanks so much. I know you had a hard stop about 2 minutes ago, but we really appreciate it. And you have family in Boston. If you're ever in the Boston area, we're only an hour away. Come up and see us.
I do. I have a son in Boston. We have 5 kids spread all over the East Coast. One, I have a daughter in Manhattan. So we go out. No, she moved to Brooklyn. Anyway, we got them all over. Will do.
All right, Greg. Thanks so much.
All right. So take me up on the offer. Send me an email. Get on my geek list. I'll get you the PDFs. You can download them, have fun, and I'll answer your questions overnight if you send me an email. Happy to help. My email's good on QRZ. Bye, folks. Happy Valentine's Day.
Thank you, Greg. Thank you. All right. So that's it for our meeting, our February meeting. And next month, instead of a speaker, by the way, we have a Meshtastic night. We're calling it like a hands-on tech night next March. So bring your Meshtastic device and we'll have some fun with that.
Good job, Ralph.
Thank you. Thank you, guys. See you later, Zoom. Good night.
Good night, everyone.